All right, let's talk about something that's probably keeping a lot of you up at night. How do we actually ship these incredible, complex generative AI systems to production safely and reliably? Because let me tell you, the answer isn't hiding in your application code. No, it's about completely rethinking the very thing we're deploying. Okay, so picture this. It's 3 a.m. Your pager goes off. The new AI service, the one your team poured months into building and fine-tuning, is going haywire in production. It's giving just bizarre answers. Maybe it's trying to use tools it has no business touching, or worse, it's hallucinating something really harmful. So you're scrambling, trying to figure out what on earth just happened. So what's the first thing you do? You check Git, right? Your single source of truth, and nothing. Git log is clean. The application code is exactly the same as it was yesterday. But over in production, it's a total dumpster fire. What you can't see in Git is that the foundational model got a stealth upgrade from the provider, or that someone in product edited a crucial prompt, or that an engineer widened the AI's tool permissions, thinking it was a harmless change. And this, right here, is the core of the problem. Your version control sees a peaceful, unchanged world, while your production environment is absolute chaos. So let's break it down. We're looking at the 4 hidden movers, the real reasons why code just isn't the whole story anymore. Your CI/CD pipeline, the thing you trust to automate deployment safely, it was completely blind. It was staring intently at the code, while the real action, the real danger, was happening somewhere else entirely. In these new Gen AI systems, the code is just one piece of the puzzle. There are 4 hidden movers that are actually calling the shots. First up, we've got the code. This is our comfort zone, right? The Python scripts, the API calls, the logic that stitches everything together. It's the conductor of the orchestra. It tells everyone when to play, but it doesn't write the music. It sets the stage, it calls the AI, but it is not making the intelligent decisions itself. And that brings us to the second mover, the models. And this is the big one. This is the component that actually decides. It's the brain of the operation. We're not just talking about some static library here. This could be a massive base model from a provider, like a GPT-4o, or could be one of the dozen highly specialized variants your own team has spent months fine-tuning. Either way, it's a live, dynamic runtime dependency. And when you change the model, you change everything. Third, we've got prompts. And please, we have got to stop thinking about these as just simple text files. A prompt isn't just a suggestion. It's a program. It's the source code for the model's behavior. It sets the persona, defines the rules of engagement, and tells the model exactly how to operate. A single word change here can have these enormous cascading consequences downstream. You could literally invalidate months of careful fine-tuning with one careless edit. And number 4, tools and policies. Think of this as the yin and yang of AI capability. Tools are what give the model its superpowers, the ability to browse the web, to query your internal databases, to actually do things in the real world. And policies? Well, policies are the exact opposite. They are the hard and fast guardrails, the non-negotiable rules about what the system can never do. Together, these two define the AI's entire operational sandbox. And all of this leads to a really stark conclusion. I love this quote. If CI/CD only sees code, it is blind to the most dangerous changes. It just hits the nail on the head, doesn't it? If your entire deployment strategy is based on tracking code commits, you are completely missing the changes that are the most volatile, the most unpredictable, and frankly, the most dangerous. So, okay, that's the problem. It's a big one. How do we fix it? How do we get our sight back and move from this state of chaos to a state of actual control? Well, the answer is to completely redefine what we're deploying. We need to stop thinking in pieces and start thinking about a single deployable unit. We need to talk about the Gen AI artifact. So what is this Gen AI artifact? It's simple, really, but it's a huge mental shift. We have to stop shipping code diffs and start shipping behavior bundles. The artifact is a single versioned package that contains all 4 of those hidden movers we just talked about: the model, the prompt, the tools, and the policy. All of it bundled together. They have to move through your CI/CD pipeline as one single atomic unit, no exceptions. And look, this isn't some abstract, high-level theory. This is a real, concrete thing that lives right inside your code repository. You create a dedicated directory, say /GenAI artifact, and inside it, you have these 4 simple configuration files. And that folder becomes the single source of truth for your AI's behavior. Not the application code, but this bundle. This is what your CI/CD pipeline needs to be watching. All right, so now that we have the concept, let's really dig in. Let's perform an anatomy of this behavior bundle. We're going to deconstruct this artifact, file by file, to see what each piece really controls and why it's so critical. Okay, first up, model.yaml. Think of this as the runtime intelligence contract. This file is where you explicitly declare which provider you're using, which specific model version, and all the key parameters like temperature or top_p. And let's be super clear. This is not just some implementation detail you can hide away. This is a core dependency that defines the very reasoning capability of your system. And changing this contract has serious consequences. You see the risks here, right? A provider pushes a minor version update, and suddenly the model's reasoning abilities just drift. Your latency and, more importantly, your cost profiles can go through the roof overnight. So what does this mean for your pipeline? It means any change to this file, no matter how small, must trigger a full end-to-end evaluation. It must go out as a slow, careful canary release, and you absolutely must have the ability to roll it back in a split second. Next, let's look at prompt.yaml. And again, I'm going to keep saying this is the executable behavior definition. This is the source code for your LLM. It defines the system's persona, its core instructions, and the precise format you expect for its output. It's a program. And the takeaway here could not be more clear. A prompt change is a production change. Full stop. A single poorly worded sentence can introduce new hallucinations or break your entire compliance posture. It can even change how the model decides to use its tools. So just like code, every single change has to be tested, it has to be diffed so you can see exactly what changed, and it absolutely has to be gated by a formal review process. All right, on to tools.json. This file defines what we call the AI's capability surface area. Anytime you give a model a new tool, whether it's access to an API, a database, whatever, you are effectively promoting it. You're turning it into a privileged actor inside your system architecture. And that has huge security implications. So managing these capabilities becomes a critical security function. This is where your CI/CD pipeline needs to act like a security guard. It must enforce a strict allow list of approved tools. It should be running automated tests, looking for any signs of permission escalation. And crucially, it has to be configured to fail the build instantly if the model ever tries to use a new or unapproved tool. No questions asked. And last but definitely not least, we have policy.yaml. This file is for all the critical constraints that your application code simply cannot enforce on its own. It's for defining what the AI must never do, things like giving out financial advice or leaking personally identifiable information. These are behavioral guardrails for an unpredictable system. And just like the others, this file isn't just a suggestion, it's a machine-enforced contract. Your CI/CD pipeline should be reading this file and automatically running tests to check for policy violations. If it finds one, the build fails. Period. What this does is create a perfect, immutable, auditable history of your system's safety roles. And believe me, when the auditors come knocking, you'll be very glad you have this. Okay, so we've done all this work, we've defined the artifact, we've built the pipeline around it. What's the big payoff? Well, it's this. You fundamentally change the nature of what you're shipping. You're no longer just pushing code, you are shipping controlled intelligence. And your deployment process, which was once chaotic and scary, becomes simple, predictable, and safe. Step 1. You version the entire behavior bundle as a single unit. Step 2. You run all of your automated evaluations against that specific immutable version. Step 3. Only after it passes everything do you promote that validated snapshot to production. And the most important part, step 4. Because the entire behavior is encapsulated in one artifact, you gain the power of instant rollback. If anything goes wrong, you can revert to the last known good state in seconds. You know, the source material for this has a line that's, well, it's pretty blunt, but it's true. It says that if you can't point to a single concrete versioned artifact and say that right there, that is the exact bundle of behavior running in production, then you don't really have GenAI CI/CD. What you have is hope-driven deployment. And that really is the question we have to ask ourselves, isn't it? Take a hard look at your own systems, at your own pipelines. When you push a change to your AI, is your process built on hope or is it built for control?